Hello and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In the last video we started talking about the special methods in Scala. Some of these were actually special methods that are interpreted in special ways by Scala, and others were just different naming conventions. The ability, for example, to use symbolic names in Scala, which isn't really an option in a lot of other languages. However, we didn't get through all of the special possibilities. In fact, we have kind of what might be the most single important special method is remaining to be discussed, along with its counterpart, which is quite possibly not as important. But both of these are fairly significant. And there's one other detail to naming methods that needs to be discussed. So, to help motivate this, I want to look at an example of something. Okay. So the idea here is dealing with functions. And let's do something like this. Val f equals x is a double rocket x times x. Okay. Now, I'm defining a function here, and I'm doing it with a function literal instead of using def, because I think that potentially helps to illustrate things a little bit better here. And of course, I can do something like that. And the question is, what's really happening there? I've mentioned before that all values in Scala are objects, and I've said explicitly, functions are objects. But the way that you invoke things on objects is not with a syntax like this. It's with a syntax of something like dot method you want to call, and then you pass it an argument. Okay, that's the standard syntax, or in theory you could have done something like that in Scala as well, using the operator notation. And that begs the question, what's going on here? Closely related to this, for example, is if we create an array like this. Okay, well, what's going on here? Well, I'm going to tell you right now, this array is an object. Okay, it's a type of declaration that we'll talk about fairly shortly. And I've just put parentheses after it. I've treated this object like a function. Same thing is happening here. And so the question becomes, well, how, if we were writing our own class, how could we make it so that class could be treated like a function? How can we make it so that we can do something like this? And also, like that. Okay, I got back res1 is this array here. It's definitely an object because we can also do, okay. So what is going on here? Well, it turns out the special method in this case is a method called apply. Okay. And when Scala sees an object followed by parentheses, so when it looks like you're trying to use an object as a function, what it does is it expands it out and it just says, oh, you're calling the apply method. And then it takes that argument and it passes it into apply. So in our previous example, array.apply 1, 2, 3, that's what that was actually doing, f.apply of 2. Okay. So all of these cases where you're doing this is just a syntactic shortcut that Scala allows you to do, and when it sees that, it actually fleshes it out and gives you and makes a call to the apply method. So if we quit out of this and we go back to the vector class, or vect3 class that we started last time, one of the things about a vector that might be helpful sometimes would be to treat it like a little array that has 3 elements in it. So I might want to have the ability to, instead of saying v1.x to get something, it might be nice to be able to say print line v1 sub 0. And have the sub 0 be the x, and the sub 1 be the y, and the sub 2 be the z. that can do things like make it easier to define dot products or something. It's really not that important for something that's only 3 long, but it still makes a nice example for us to illustrate this. And as this is written right now, this won't work. And if we read the error message, vec3 does not take parameters. Okay, so that's this problem that we have. And the way we can fix that is that we can do a def of an apply method. And what do we pass into here? Well, because basically what we're doing is we're indexing, the thing that I passed into here is an int. And I can even call it index. And what is this going to return to us? Well, it's going to return a double. Now, I guess there are multiple ways of doing this. One way would be to match on the index. Case 0 goes to x, case 1 goes to y, case 2 goes to z. Now, the way that's written, if you do anything else, you're going to get a match exception. And maybe that's what we want. Maybe it's not what we want. We've already seen that if you try to index something that's out of bounds on an array, you get an exception thrown. And so maybe having an exception thrown here would be appropriate. In that first vector, the x value is 1. And so this printout down here printed that. So you can take any class that you want and you can put an apply method into it, and it will allow it to act like a function. And you might not have been thinking of things like indexing an array as a function, but really that's what it was. You were passing an argument into the array, and that argument was an index, and it gave you back the value that was at that index. That's basically exactly what a function is supposed to do. The fact that Scala allows you to do this is why arrays in Scala look exactly the same as every other collection, why they don't really have to be special. It turns out that in the compiler they wind up being special, but to the programmer it doesn't matter. An array works, the way you code for it is just like a list, and it's just like a vector or a range or a number of other types that we'll talk about later, and all of those types exist inside of the libraries. There's not actually stuff built into the language itself for that. It's just that Scala has this flexibility so that you can do things like write your own apply methods to be able to, quote, index into things. Now, instead of just being able to index in, you can also treat it as a more general type of function. Indexing just happens to be one of the common uses. Now, in this case, we made it so that all of these were vals, and so you can't change them, whereas our vec3 is immutable. What if our vec3 was mutable? What if I wanted these to be, instead of vals, these are vars? Note, I don't really want this, but if I had that, then I should be able to do something along the lines of print line v1 sub 1, just first v1 sub 1 equals 99. This is just like an assignment into an array that we've seen before. And if you can index it, then and it's mutable, it makes sense to be able to do this. Now, of course, if it's not mutable, like in the case of a list or in the case of what we actually want our vec3 to be here, you shouldn't be able to do this. But just so I can demonstrate to you how it would be done, what if I did want to be able to do this? Well, in that situation, there's another special method. So once again, this doesn't look like a method call. And maybe it's worth putting in a comment here saying, so v1 sub 0 expands to v1 dot apply of 0. And in this case, v1 1 equals 99 expands to v1 dot update 1 comma 99, not I, 1 comma 99. So the counterpart to apply is update. And you should only put update inside of things that are immutable. Okay, if it's not mutable, don't put in an update. And it takes a first argument, which is effectively the index that you want to be updating, and a second argument, which is the value that you want to set it to. And so right now, once again, this code should not run because there's no update on the vec3. Of course, we can change that. Def update index is an int, value is a double, and let's go ahead and say returns unit equals index match, and I'm going to once again use the match here and just have it be the entire body of the update. It will throw an exception if it's not happy. And then we do assignments into the appropriate variable x, y, or z. And now if we run this, you can see that these last two lines, when we print out the v1 sub 1, which is the y value, which had originally been set to 2, this line right here actually changes it. And so it looks like you're doing an assignment into there, and Scala just converts it up to this. So those are our special methods. Now, the fact that we have that we have the apply and possibly the update actually brings forward another special type of thing that you need to be aware of. You need to be aware of how it works. And this is called overloading of methods. When we were writing scripts previously, and in part because we were just writing scripts not inside of classes, we made every function have its own name. And if you ever made a function that had the same name as another function, what would happen is the second one would generally hide the first one. If you're writing inside of a class, and later on as we put everything inside of classes, that is not going to be the case. We are going to hit we have the ability to write multiple methods that have the same name. And in the case of the special methods, now for a lot of situations, you don't want to have two methods of the same name. That can be confusing. But sometimes it really makes sense, and sometimes in the case of special methods, you really don't have a choice. If something is going to be called apply, so if you had something and you should be able to index into it or treat it like a function that takes an int, or maybe it takes a tuple of int string, who knows? Or maybe it just takes a string. Well, the single apply method isn't going to do this, and so you need to have two apply methods, one that takes just the int and the other one that takes whatever the other thing is. And that means now, okay, we have two methods that are named apply. That is allowed because you are allowed to overload methods. You are allowed to have two methods that have the same name on the condition that what you pass into them is different. Okay. And ideally, they would have different numbers of arguments. So one would take one argument and the other one would take two arguments. If you're going to do it with different types of arguments, that will still work, but just you need to be careful to make sure the types are very different. So for example, if one takes an int and the other one takes a double, that can actually in some situations cause confusion because you might get things that aren't happening quite the way that you wanted them to. So you can create two methods of the same name, but they have to take different parameters. And when we talk about inheritance later, we can talk in more detail about why exactly it is that you have to be careful here, because there are some other situations where you can have it take two different types, but they are closely related enough that which version gets called is kind of sensitive to exactly what the programmer has written. And in those situations, the programmer is likely to mess something up. And so as a general rule of thumb, you should avoid doing things in your code that make it easier for you or someone else using your code to screw things up in the future. You want it to be as hard as possible to screw things up, because as you have definitely learned by this point, it's easy enough to do that anyway. So don't make it any easier than it needs to be. So that closes out our discussion of special methods. We've seen that we can have symbolic methods. We've seen that we can do unary methods. We also saw how you can do assignments into things, so you can make things that aren't really vars, but they look like vars, because you can access them with a method that just has the name of the property, and you can do an assignment to them by calling a method that was an appropriately named special method in there. And then in this video, we looked at the apply and the update methods, so that you can actually take any object that you want and turn it into a function. So that's it for this video, and hopefully we'll see you again soon.